Hello everyone. As I promised the other day, I'm making a video about this. This is a 1987 vintage handheld laser pointer. These were the biggest thing available at the time, most powerful lasers that you could hold in the palm of your hand. This particular one ran off of two 9-volt batteries. Requires 18 volts to operate, and it produces 1 milliwatt of laser energy. Probably less than that now. But I figured we'd take a look at it, see how it works, and explore a little bit of technology history. Now, anyone who did big presentations probably had something similar to this, if they were anyone of note. But you can see it's very large. It's about 6 inches long and about 2.5 inches high by 1 inch wide. And even in my hands, that's big and chunky, and it's not all that light. With a couple of batteries in this weighs quite a bit, and it would get tiring to wave it around for a 2-hour lecture. And it's a far cry from the little teeny tiny lasers you can buy today. And actually, I have here, this is actually about 10 years newer than this. This is about a 1997 vintage red laser diode that I pulled out of an old gun site. And we'll be comparing the output of this to this. This is a 5 milliwatt laser diode, whereas this is a 1 milliwatt tube driven laser. So first thing we're going to do is we're going to hook this up to the power supply, since I don't have any batteries, and we're going to have a quick look and see how bright this laser is. So what I've got here, the leads from my power supply, and we're going to set the voltage on the power supply here to 18 volts. And clip the leads onto the battery contacts. And untangle the leads from my cell phone charger. We'll give it some power here and have a look. So that's this laser here. Not very powerful, not very bright. Like I said, less than 1 milliwatt of laser energy. And to produce that, it's using about 5.7 watts of electricity to produce that little tiny dot of laser energy. Not very much, not very bright. You certainly wouldn't be able to see that at any distance in a lecture hall or anything if the lights were on, but you'd probably still be able to see it against a fairly dim projection screen in a hall with the lights turned out. And now we compare that with the laser diode. Now you notice it produces a more rectangular dot. Technically with this is it's a line laser. But the big thing is the power draw. It's a much brighter laser dot, and like I said, this laser diode's rated 5 milliwatts, and you can see it's drawing 0.04 watts. So to compare those, this helium neon laser drew 5.66 watts. The laser diode drew 0.04 watts. That's about 140 times the amount of power drawn by the tube laser versus the laser diode. And the laser diode puts out 5 times the amount of laser energy. You can see the efficiency of the solid state laser is far, far greater than that of the tube laser. But we aren't here to discuss efficiency of laser products. What we're here to do is take this apart and see what makes it tick. So let's get in here and take these screws out. Now, I will admit I have had this open in the past, not in recent history, but I have opened it up when I first got it. First thing I did after I played with it for a few minutes was to pull it apart. I pulled this out of a junk bin of stuff that was being thrown away at an office because I've got a thing for anything having to do with lasers. So, got the screws out. Alrighty, here we go. The first thing that I see right off the top of my head is big ceramic capacitors, and this entire board has been gooped over with insulating compound, as this is a high voltage driver board. Let's go ahead and pull the rest of this out as much as we can. That's connected there, and I don't want to destroy this. Now we've got a flex ribbon here. Oh, that's interesting. That's burned and melted through. I'll have to trace that circuit and see what that was for. It's burned and melted through on this end too. Oh, someone repaired it. There's a bodge wire here. There's a wire going down to where that was connected. So someone had to go at repairing this at some point. Anyway, we've got our laser tube, a high voltage driver coil here, or a driver assembly, and I cannot see what's in there, but I'm going to guess that this is a series of capacitor driven voltage doubling circuits. And we've got the laser aperture on this end and the reflective end here. And the way these tubes work is it's filled with helium and neon gas, quite similar to what you would find in a neon sign, for example. But the difference here is when it's excited, when the gas is excited by the electrical current, the light energy is captured by the reflective surfaces. And there's a mirror at this end that is 100% reflective, and a mirror at this end that's only partially reflective. And how much depends on how many times they wanted the beam to bounce inside the tube before exiting. But what happens is the light as the gas is excited and produces light, the light bounces back and forth between these two mirrors, and as it's bouncing back and forth, the photons become aligned, and then once it's reached a sufficient amount of energy to overcome the partial reflectiveness of the mirror, it comes out as a columnated beam of laser energy. Now up here on the switch, got a big ass coil there. So we've got a switching transistor here. It's a BDX37. And it's probably handling the high voltage switching. I say high voltage because this is up to 120 volts switching voltage. So what's probably happening here is the power from the batteries comes in here. Oh no, this is an oscillator circuit. And there's a surface mount chip there. I can't see the numbers on it. So there you have it. This is an old style helium neon laser tube. And I would demonstrate it running, but one of the wires, that bodge wire that was connected there, just popped off. So I'll have to solder that back together before this will work again. But yeah, we've got a fairly simplistic circuit. 18 volts of power comes in, comes up here to this board here where it is stepped up. The higher voltage after it's stepped up here comes back to the driver board. The driver board steps it up even further to probably several thousand volts to drive the laser tube itself.